Hello everyone, welcome to this video. In the previous video we have learned about the Fourier integral representation of the function. So that means whenever we are required to see the integral representation on the given function on the whole of the real line, right? In that case we could use this representation where we represent the sums instead of these integrals. So instead of using the sums, we now use the integrals. So let us use this definition in order to solve this particular question. So in the question they are asking find the Fourier integral representation of this function. Now this function is defined on whole of the real line, right? So the interval here we have is from minus infinity to infinity. So for this interval over here we are required to calculate the Fourier integral representation of the given function. So for that we have to use the given expression, this one. So for that we are required to calculate this a omega, b omega, right, in order to solve this. And further we want, in the question they are asking also show that, so let me write down here, they are saying also show that integration from 0 to infinity sine x by 2 divided by x dx, that is equal to pi by 2. Now this kind of integral is a difficult integral to solve. Why? Because it cannot be integrated directly. So for that we may make use of this Fourier integral representation for the given function. So let us see how we can do that. So for the solution, let me first calculate this a omega. So if you see at the definition for this a omega, that is integration from minus infinity to infinity f of t cos omega t dt. So this is nothing but integration from minus infinity to infinity f of t cos omega t dt. So now your function is defined in a piecewise sense, so that means you have to break your integral onto the limits 0 and 1. So you'll write minus integration from minus infinity to infinity of this function. Now in this particular integral the value of the function is 0. So instead of f of t you can write 0 here, right? So you have 0 into this thing plus the next integral value is from 0 to 1. Here the function's value is equal to 1, so I can write 1 into cos omega t dt. And for the third case, when I will define the integration from 1 to infinity, the function's value is again equal to 0. So 0 into cos omega t dt. So that your a omega now becomes equal to integration from 0 to 1 of cos omega t dt. So its integration is quite simple. So you have sine omega t divided by omega, and the limits of integration of t, they varies from 0 to 1. So that means I can write omega outside. So sine omega, so it would be, when you substitute the upper limit, it would be sine omega, and when you substitute the lower limit, this would be equal to sine of 0. So sine of 0 is 0. So this is the value of your a omega, right? So next let us determine what is b omega. So according to formula we have b omega as integration from minus infinity to infinity f of t sine omega t dt. So again I can break this into 3 integrals. So we have integration from minus infinity to 0, function's value 0 into sine omega t dt. This is the first integral. The second integral is from 0 to 1. The function's value is 1. So we have 1 into sine omega t dt. And for the third integral, we have integration from 1 to infinity. The value of function is 0 into sine omega t dt. So that we are only left with this middle term. So we have sine omega t dt. So when you perform the integration of sine omega t, so this is equal to minus cos omega t divided by omega. and here the limits of integration, they vary from 0 to 1. So you can take this 1 by omega minus outside. So this would be cos omega minus of cos 0. And what is cos 0? Cos 0 is equal to 1. So you simply have 1 here. So the value now becomes equal to 1 by omega 1 minus cos omega. So this is the value of b omega that we require in the integral representation of the function. So let me write down here, therefore, the Fourier integral representation of the function f of x, that is given by, so let me see the formula here. The expression is this whole expression, right? So we have calculated our a omega and b omega, so we can substitute the values here, and the other terms are as such. So therefore this term becomes equal to f of x, that is equal to 1 by pi integration from 0 to infinity a omega cos omega x. So I am writing down the formula first, right? Plus 1 by pi integration from 0 to infinity d omega sine omega x d omega, right? Here also we have d omega. So now I can substitute the values. So it would be 1 by pi integration from 0 to infinity. In place of a omega, the value I obtained is 1 by omega sine omega. So it is 1 by omega sine omega cos omega x d omega. Now you cannot move this 1 by omega outside because the integration here is performed with respect to omega. So you have 1 by pi integration from 0 to infinity. In place of b omega, I can now use this value. So I have 1 by omega 1 minus cos omega, right, into sine omega x d omega. So this is the value. Now what I can do, I can merge these two integrals so that I would have integration from 0 to infinity. So I can write this to be 1 by omega is common in both of these, so I can take this to be common. So I'll be left with sine omega cos omega x plus 1 minus cos omega into sine omega x, right? No problem writing this. We have just clubbed the two terms. So once you wrote this thing, so you can now rearrange the terms so that you obtain f of x equal to 1 by pi integration 0 to infinity 1 by omega as such. Now in place of this sine omega, can you use the double angle formula? So according to that, you would be getting 2 sine omega by 2 cos omega by 2. Now what we are to do, we have written the Fourier integral representation as this term, right? But in the question they are also asking we are to determine this thing. So I am proceeding over to that. So here I have written in place of sine omega the value 2 sine omega by 2 into cos omega by 2, right? And cos omega x as such. And then in place of 1 minus cos omega, I can also use the double angle formula. So this thing becomes equal to 2 sine square omega by 2, right? Into cos omega x as such. So this is what we have here. So I can also rearrange it a little bit over here. So I have 1 by pi as such, integration from 0 to infinity as such, and then now I can take this 2 common, so it would be 2 by omega, and then I can also take sine omega by 2 common, so it would be sine omega by 2, and then in the brackets I would be left with cos omega by 2 cos omega x plus sine omega by 2 cos omega x. I'm sorry, here we should have sine omega x. Okay, so this term is sine omega x. Now look at this term. This term is cos A cos B plus sin A sin B. So we can use the sum formula. So this term would become equal to cos A plus B. So we have cos omega by 2, or this term would not be cos A plus B, it would be A minus B. So I could write this to be cos omega x minus omega by 2 d omega, right? So we have the value of f of x as equal to 1 by pi integration 0 to infinity 2 upon omega sine omega by 2 cos of x minus 1 by 2 omega d omega. Now this is the simpler version of the Fourier integral that we obtained. Now if you look over here in the given integral, we require sine x by 2 and no cos term is required. So we want this term to become equal to 0. Why? Because cos of 0 is 1. So that means if I substitute x is equal to 1 by 2 here, therefore your f of 1 by 2, that becomes equal to, now look at your function. The function value at 1 by 2 lies within these limits 0 to 1. So the function's value is equal to 1 here. So I can substitute all these values in the given equation. So I have the value of f of x as 1. So this would be 1 by pi integration from 0 to infinity 2 by omega as such, sine omega by 2 as such, and then this would become cos 1 by 2 minus 1 by 2. So this would be 0 into omega into d omega. So now this term is equal to 1. So we have 1 is equal to 1 by pi integration 0 to infinity 2 upon omega sine omega by 2 d omega. Now what I can do, I can replace the variable here. So instead of omega, I can write x here because omega just serve as the dummy variable representing the integration. So what I can do, I can replace this omega by x. So we have 2 by x sine x by 2 dx. So that from here I can shift this to the left hand side. So I have pi by 2, this 2 also to the left hand side. So pi by 2 becomes equal to integration from 0 to infinity of sine x by 2 divided by x dx. So this is what we were required to prove, that this integration was equal to pi by 2. So you saw how you can use this Fourier integral transform to solve difficult integrals, and moreover this is also used to represent the given function which is piecewise continuous over the whole real line as the integral representation. So that is it for this video. Thank you for watching.